Welcome back to the second session of physics class in the chapter Physical World. Friends, as I said, today we are discussing about the fundamental forces in the nature. So whatever I explained in the previous class, it is just an introduction to the physical world. Now, today we are discussing about the fundamental forces in nature. First question is there force? Yes, there is. There are. Then, how many fundamental forces are there in nature? If we name them, there are 4 fundamental forces in nature. There are 4 fundamental forces. There are 4 fundamental forces in nature. Number 1, gravitational force. Number 1, gravitational force. Number 2, electromagnetic force. Electromagnetic force. Number 3, strong nuclear force. Number 4, weak nuclear force. Friends, in the examination, this is not for examination. Whatever I explained in the previous class, just is the introduction. So now, in the examination, Chapter 1 carries total 2 marks for the annual examination. In that, the question number 1, in part A, they may ask a simple question. How many types of fundamental forces are there in nature? 4 types is the answer, that's it. Or mention any 2 fundamental forces in nature. Out of 4, you can write any 2. That is gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Out of 4, you can write any 2. This is regarding the examination. So now, if I go in detail with all these fundamental forces, there is gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. So let us start one by one. If I take the first one, gravitational force. The dictionary meaning of gravitation is attract. Gravitational force. If you write down, or if you check, or if you want to know the meaning of gravitation, the dictionary meaning of gravity means what? Attraction, something is pulling, right? So we are all under gravitational force. With the 2 gravitational force we are experiencing right now. One is with respect to the sun, another is with respect to the what? Earth. We are experiencing 2 gravitational forces. Suppose if I start with this gravitational force. So some explanation is required. Don't worry if you won't follow, because we are studying once again the entire chapter under one topic called gravitation, chapter number 8. That there we are studying the chapter called as gravitation. No need to worry about this. What exactly is happening in the gravitational force? There is heavenly mass bodies there. This is attracting another, say, heavenly mass object. This is pulling towards it and this pulling towards it. There is a mutual. So, this, say, in 10th or in the 9th standard you studied about this. The gravitational force between any 2 celestial bodies. The gravitational force between any 2 bodies, our heavenly mass bodies, is directly proportional to the product of, suppose if mass is m1, if mass is m2, if they are separated by say r or d or l, you can measure any distance. So now, then it is given by the electrostatic force, the gravitational force between 2 mass objects is directly proportional to the product of masses and inversely proportional to the square of the distance between them. And if I remove this proportion by a constant, then I get F equal to G into M1 M2 divided by R square. The G here is the gravitational constant and its value is given by 6.67 into 10 raised to minus 11 kg meter square per, so Newton meter square per kg square. These are all not required now. This right now we will discuss in detail in chapter number 8. Then what have to study here? We have to study the properties of gravitational force. So if we start with the properties. First property. Gravitational force is the weakest force in the nature. Weakest force in the nature. So now, how many fundamental forces we have? We have 4 fundamental forces. Out of 4, the gravitational force is the weakest force. So now, in the examination, they'll ask for 1 mark. Part A, Roman number 1. In that first question, they may ask, name the weakest force in the nature. So the answer, gravitational force. Second thing is, it is a long range force. It is a long range force. Long range force means it is applicable at any distance. Even sun is very, very far away from us, but yet we are experiencing the gravitational force due to the sun. So hence we can say it is a long range force. Next one, it is a central force. It is a central force. What is the meaning of this central force? Suppose if I take 2 bodies of mass M1 and M2 separated by a distance say R, mass 1 will exert a force on mass 2 not from the surface, it is from the center. So gravitational force is a central force. That means if one body exerts a force on another body, it is not from the surface, it is from the core of the body or the center of the body. Then next point is the gravitational force obeys inverse square law. Inverse square law. What is the meaning of this inverse square law? Just a few minutes back, I explained an equation, that is F is equal to G into M1 M2 divided by R square. If you look at inverse square, where is square here? Square is in the denominator. Then what is R here? R is the distance between the 2 masses. Hence, as the distance between the 2 bodies increases, F decreases. How? Square of the distance. Hence, in classical mechanics, most of the phenomena are obeying inverse square law, I can say. The next thing is gravitational force is a conservative force. Gravitational force is a conservative force. What is meant by conservative? The meaning conservative is neither nor means is neither be created nor be destroyed. So hence gravitational force is a conservative force. And the next one is gravitational force is not affected by not affected by the motion of the bodies. What is the meaning of this? Suppose if I move from this place to another place, will gravitational force changes? No. Meaning is very simple. That means it is not affected by the motion of the bodies. In body, I will say body or bodies. So that means what? Even if I carry this object from one place to another place, any distance, doesn't matter, the gravitational force on this object remains same. Then, next point is the gravitational force between two objects. Gravitational force between two objects or two bodies, two objects is not affected by the presence of another body. What is the meaning of this? Suppose, say if I have two objects. Let us say if I have two objects. Object 1 is this pencil and object 2 is another pencil. They are separated by a small distance, say r. Now, if I place another object between or in between or nearby any point, the gravitational force between these two objects will not be affected by the presence of this other body. Suppose if I remove, gravitational force remains same. If I keep, the gravitational force remains same. That means what? The gravitational force between two bodies will not be affected by the presence of another body nearby. Understood this? So now, with this, you can conclude the properties of gravitational force. Still many are there. For your level, this much of properties are sufficient. Now, friends, as I say, from this chapter, it carries only 2 marks in the annual examination. Instead of preferring for 1 mark, say, name the weakest force in the nature, gravitational force. Name the weakest force in the nature, gravitational force. Instead of this, they may ask 2 mark question. Part B, Roman number 2, in that question number 11, they may ask for that, mention any 2 properties of gravitational force. I repeat, mention any 2 properties of gravitational force. Out of 7, you can write any 2. Weakest force in the nature, long range force, central force, it obeys inverse square law, is a conservative force. Write any 2 properties. That's it. Now, let's move on to the next force, that is electromagnetic force. We are studying the second property of fundamental force, electromagnetic force. Friends, this basically deals with electrons or the charges. When the charges are in motion, they not only produces the electricity, also produces magnetic field around it. Together we can say electromagnetic force. Together they exert a force called as electromagnetic force. And if I write the fundamental equation of this force as we wrote in the gravitational force, this is the force between, say, consider 2 charges, say Q1, Q2, separated by distance, say R. Then F is directly proportional to, as we wrote there, it's the product of 2 masses. It is also the product of magnitude of 2 charges, Q1 and Q2, and inversely proportional to the square of the distance between them. While explaining point number 4 in the gravitational force, I say gravitational force obeys inverse Even in the gravitational force equation we had F equal to G into M1 divided by R square. Here also we have F is directly proportional to V1 divided by R square, and if I write properly I can write here F is equal to 1 by 4 by epsilon naught Q1 Q2 divided by R square. Look at this. It is also obeying inverse square. So then some properties of these fundamental forces are common. Look at this. Here also it obeys inverse square law, and probably same thing here also, electromagnetic force. That means fundamental among the electromagnetic force properties. So it obeys. It is also obeying what? Inverse square law. So no need to worry about this equation and this explanation because it will come in second year. So now time being we study only the properties of electromagnetic force. Properties. Let us start one by one. If I write the properties of gravitation, properties of electromagnetic force, friends, look at this. While explaining the gravitational force, I said the dictionary meaning of gravitation is attraction or pulling. But if I go to the electromagnetic wave, it may be attractive or it may be repulsive. So I can write here, it may be attractive or repulsive force. Second one is, as we wrote there, it is stronger than, it is 10 raised to plus 36 times stronger than gravitational force. Gravitational force. Suddenly don't come to the conclusion that electromagnetic force is the strongest force in the nature. Only you can say that gravitational force is the weakest force. But if I compare the gravitational force with the electromagnetic force is 10 raised to plus 36 times greater than that of the electromagnetic gravitational force. And third point, I can write here, it is also a long range force. It is a long range force. Next one, D, I write same copy, obeys inverse square law. Inverse square law. Next thing is, as we wrote here, F is equal to K into Q1 Q2 divided by what? R square. This gravitational force in detail was explained by Isaac Newton, and whatever I wrote here, F equal to K into 1 by 4 by epsilon naught into Q1 divided by R square was explained by Coulomb's. So it obeys Coulomb's law. It is this, or it is governed by Coulomb's law. So here we have total 5 important properties of electromagnetic force. Again, in the examination, if they prefer for 2 marks, then they may ask, mention any 2 properties of electromagnetic force as question number 11. I repeat once again, in part B, Roman number 2, question number 11 will be, they may ask, mention any 2 properties of electromagnetic force. At that time, you can write any, maybe attractive or repulsive. It is purely attractive. You can write one more property. Gravitational force is attractive force. That's it. That is also one property. The dictionary meaning itself is one property. Gravitational force, attractive force, the weakest force, etc. You can write here. And when it comes to the electromagnetic force, it may be attractive or repulsive. It is similar to plus 36 times stronger than the, greater than that of the, gravitational force. It's a long range force. It obeys inverse square law. It is governed by Coulomb's law of electromagnetic. So you can say this Coulomb's law asked, what that? Mention any two differences between, I repeat, compare gravitational force with the electromagnetic force, or compare electromagnetic force with the gravitational force, or distinguish between electromagnetic force and the gravitational force. So at that time we will have to compare any two properties in one side, two properties in another side. Friends, in the next class we will study the remaining two properties, or the properties of the remaining two forces, that is strong nuclear force, weak nuclear force, some conservative or the fundamental laws of physics in the next class. Thank you.